your expertise. Thank you, sir.
Thank you, madam. Very good afternoon, you all. In absentia, the Honorable Founder Chairman of KIT Bhubaneswar, Dr. Achyuta Samanta, the esteemed Chancellor of KIT, Dr. Ashok Parija, the esteemed Vice Chancellor of KIT, Dr. Saranjit Singh, the Dean, Dr. B. Surekha, the coordinator of this program, Dr. Smritirupa Pradhan, and also the co-coordinator, Dr. Nilotpala Bez, all the invited guests and the delegates, all the research scholars, students, participants, press and media. Very good afternoon, you all. I am Dr. Gunamani Jena, working as a professor in the CSE Department of Roland Institute of Technology, Barampur. And I welcome you all to the last session of the 6-day ATAL online FDP program. And I have been assigned my topic today, a framework for sustainable manufacturing and integrating Industry 5 technologies with also Industry 5 values. So dear friends, in this series, this is my second session. And first of all, let me thank, even if in this busy session, because the university exams and the academics end of the semester, they are able to, I think, gather more than 60 candidates, and the last day it was 100 plus candidates. It is a great effort. And the FDP, auto FDP, what they have selected, the topic and title with the current age and most appropriate things at this moment. So without wasting our time, so let me focus on the, just give me time to share my things. I hope, is the screen visible? Can I get a confirmation from any of the participant?
Yes, sir, it is visible.
Yes, sir, visible.
Fine. So once again, I welcome you all, dear delegates and also researchers. These 5 minutes, I will take the introduction of this sustainable manufacturing and integrating Industry 5 and all the Industry 5 values. Then we will move to the original work or original thing related to, it is a framework for the sustainable manufacturing with integration of Industry 5 and values. As we know, in this introduction part, I will tell you a few things. The sustainable manufacturing, it refers to the creation of manufactured products through processes that minimize negative environmental impacts, at the same time conserve the energy and the natural resources, and prioritize the well-being of workers, communities, and also the environment. You can understand, it is not only worried about the production, at the same time, it want to give priorities of the well-being of the workers or the communities who are there, and also the environment. It aims to balance economic growth with ecological and social responsibility, creating a model that is resilient, efficient, and forward-looking. So this is the main thing we understand by this sustainable manufacturing. And once upon a time, it was considered, or the importance of this sustainable manufacturing, it was considered as optional. So people are not giving that much importance there. But it is essential for business to remain competitive while safeguarding the planet and society. So exploring these solutions can lead to a future of innovation and growth while addressing environmental and societal changes. Now, this sustainable manufacturing is an evolving paradigm that addresses environmental, economic, and social sustainability in production process. Mainly, how it is related to the mechanical and the manufacturing part, that is the things we are focusing today. And with the emergence of this Industry 5, which emphasizes human-centric, sustainable, and resilient production system, there is a growing need to integrate advanced technology with values that align with these principles. So we will try to understand what are these different industry things here, evolutions, and how we add the values and we apply for the sustainable manufacturing. And this framework, which explores how Industry 5 technologies can drive sustainable manufacturing while upholding the values of the sustainability, inclusivity, and resilience. Fine. So now you see this Industry 5 is purely human centric, what I want to say. Now, scenario in the 20th century, let us see, and what is the impact on this environment. In the mid 20th century, the rapid growth of manufacturing and industrializations ushered in an era of unprecedented prosperity. Of course, we see it, and the factories hummed with activities, mass productions surged, and also products become more accessible to millions of people worldwide. But however, as industries expanded, so did their environmental and social impact also we see. They are turned grey with pollution. Rivers ran black. You can understand now. You can see the rivers with industrial waste, and entire ecosystems disappeared under the weight of human consumptions. So this economic boom, let's see the economic boom. What is there? Of course, it has given the economic boom, but at the cost of unsafe condition. That is the important things I want to bring to your kind notice. The economic boom also came at a human cost. Workers in many parts of the world toiled in unsafe conditions, often earning barely enough to survive. You can see industry is growing, lot of production is there, but what is the social status and the condition of these workers? Communities near industries hubs, they suffered from health crisis linked to pollution, while regions rich in natural resources face deforestation, soil erosion, and also water scarcity. These are the things we see nowadays. Then the things what we see by the 21st century, these devastating consequences of this unchecked growth, it becomes very clear. Then what are the things we come across? Just 1 minute. There will be a number of things we can see. First one is the climate change. Second one is the resource depletion, the waste overload, and the consumer awareness. What we see in the climate change, it is clear. It is the December, you can see maybe 21st of December, you can see the weather, the climate. The accumulation of greenhouse gases from industries led to rising global temperatures, causing extreme weather events, melting glaciers, and also rising sea levels. Now, as you see the science news and other things, maybe within the next 1 or 2 decades, some of the cities which are adjacent to the seashore, they will be submerged. That is the scientists they are predicting. Next thing is the resource depletion. Over reliance on finite resources like the fossil fuel, like the petrol, diesel we are using, the rare earth metals, and fresh water brought the world closer to critical shortages that we see now. The then is the waste overload. The landfills overloaded or overflowed with discarded products and packaging, much of its non-biodegradable polluting landscape and also oceans. Then the most important part is the consumer awareness. A growing middle class, they become increasingly aware of these challenges, demanding, if some of you have visited the coal mines and the refilling, you can clearly understand with a slight, no, this earthquake, most of the things it will collapse, even if the residential building and all this, nothing is safe. If you go to the culture in Orissa and some other places, you can see these cases. Then demanding sustainable and this middle class or who are the some awareness it is coming to the people, they are thinking about this part. Okay, they are aware about the challenges, demanding sustainable and ethical production practices, and these challenges laid bare a simple truth, and our current manufacturing systems are unsuitable, unsustainable, and must evolve. That is the why the sustainable manufacturing is important today, right? Now, if you see in details about the sustainable manufacturing, we find a number of points here. the first and the very important point is the environmental preservations. The planet's natural resources like the forest, clean water, and fossil fuels are finite. You understand it, isn't it? So how many days maybe your grandson or granddaughter may not be able to find petrol for his, or that time also the vehicle will be different. It will be running with hydrogen or with some water or some solar, whatever things there. And without these changes, we risk losing these resources, having future generations with an uninhabitable planet. That is the most important things we can speculate. For example, let us see the fashion industry. They are contributing up to 10% of the global carbon emissions and pollutes the waterways with the dyes and also microplastics. It's clear? These sustainable practices such as using organic materials and also recycling textiles can drastically reduce this impact. Then the second important point here, combating the climate change. Manufacturing accounts for a significant share of greenhouse gas emissions. More the manufacturing, then more is the greenhouse gas emission. And what is the effect? No, there is holes in the ozone layer, all the things. The transitioning to renewable energy sources and energy efficient technology can mitigate climate change. Now, the mechanical and also other people, automobile people, they can see we are using AC, it is 5 star. That is the energy efficiency, energy consumption is less, that we can clearly see. The companies like Tesla, they demonstrate that renewable energy in manufacturing and low emission products can revolutionize these industries. Then the third point is the meeting the consumer expectations. And this modern consumers demand transparency and also the responsibility. You see, some of the products from the developing countries rejected by developed countries because they are using child labor, they are using unsafe condition for these labors, for that they are rejecting. So then these modern consumers, they demand transparency and responsibility. They prefer brands that prioritize the environment, fair labor, and also sustainable practices. If it is not there, they may not use that products, right? Then companies like Patagonia, they have embraced this by repairing and reselling used clothing, showing that business can thrive by aligning with these values. Then there are some economic opportunities also. The sustainable manufacturing, okay, we combating climate change, meeting consumer expect economic opportunity, we are coming here. The sustainable manufacturing opens avenues for innovation and new markets such as green technologies, renewable energy, and eco-friendly products, which can be easily mixed with the, which can be easily decayed. Say the use of plastic and all things, you see what is the hazards it is creating, even if the animals and also the cattle, you can see. And you see the in the biomedical also, or in the microbiology also, in the oceanography also, you see at the deep, the bottom of the sea also, these there are traces of these microplastics. Now, for instances, the solar energy and electric vehicle industries have grown exponentially, creating millions of green jobs worldwide. So this is the thing. So job market also is increasing all the thing. Then the regulatory compliances. Now you see the governments worldwide, they are enacting stricter environmental regulations. They are adopting the sustainable manufacturing practices also. That means the company who will be unable to comply all these compliances, they may lose their reputation and they may get some fines imposed on them. So that is the reason they also showing the regulatory compliances also playing a greater role. Then the social responsibility. In these social responsibilities, workers deserve safe, fair, and healthy working conditions. And the sustainable manufacturing prioritizes human rights and community well-being, also addressing labor exploitations and also unsafe practices. For example, the fair trade movement ensures that producers in developing countries earn a fair wages, breaking cycles of poverty. You can see the people who are nearer to the industry, there is a lot of production, that is a lot of sale, everything is there, but their economical conditions still there. They are still there struggling. Okay. Then what are the action call? Imagine a world where rivers run clean and air pollution is a relic of the past, and every product is designed to minimize waste and maximize the efficiency. Then what else you want? And imagine factories powered by the sun producing goods made from materials that can be reused or regenerated indefinitely. This vision is achievable, but only if businesses, governments, and consumers work together to make sustainable manufacturing, then only it is possible. It's clear? You cannot say it is only responsibility of the business people, it is the responsible of the business people, of the government, of the consumers, even if the public and the workers also. Now, the shift to sustainable manufacturing is not just about solving today's problems, it is about building a future where prosperity, innovation, and environmental stewards coexist. Without it, humanity risks losing not just its resources but also its chances to thrive in harmony with the planet. These are the important things we come across, right? Then we go for the what are the principles of this sustainable. We are only going for this introductory part of these things, then we'll move to the actual part. So, what are the principles of this sustainable manufacturing? The first one is the resource efficiency. If you see, there are number of things are concerned here. First, we go for the resource efficiency. What is the main thing here? Maximizing the use of renewable resources and reducing the materials waste during the production. That is the main thing, the resource efficient. Second thing, implementing strategies like learn manufacturing, circular economy practice, and also life cycle assessment. These are the things. Second thing is the energy efficiency. So the main aim here, reducing energy consumptions through cleaner productions technologies, smart systems, and also renewable energy sources like the solar, the wind, also the biomass. Now, which is one of the good research is going on this biomass and how to go for the bio fuels. Then the third point is the pollution reductions. If you are able to lower the emissions like the carbon dioxides or the hazardous waste and chemical runoff by adopting cleaner technologies, closed loop systems, and stringent waste management practices, then it is possible. Then we go for the product life cycle approach. Yeah, product life cycle approach. If you see it here, designing products for longer lifespans. It is not just like use and throw technology. Designing products for longer life. You see, previously we are using a pen. We can refill the ink and we are able to use one pen for the 4 years in our matriculation. Maybe for the plus two also we used one pen. That is enough. I remember up to my graduation with three pen I completed my graduation. But here every month we purchase a pen and throw it. Where it is thrown? If you imagine if there are 30 to 40 crore people, they are going to school and every month they are throwing this much of refills, then what is the status? Designing products for longer lifespans, reusability, recyclability, and minimal resource consumption. Then considering the entire life cycle of a product from raw material extraction to end of life disposal or the recycling, right? Then the fifth point is the social responsibility, ensuring fair labor practices, no use of child labor, safe working environment, the safety of this worker is important, and also the community engagement. These are the important things under these social responsibilities, right? Then contributing to the well-being of employees and surrounding communities. I'll give an example here. See, you might have seen some construction sites or some why construction so many small or minuscule industries are like that things when worker were working and even if you don't find a toilet for these gents or ladies also, so they'll be see can you imagine in the construction side we don't have a minimum facility for them, the ladies and other things. Maybe sometimes they go 1 kilometer, half kilometer
तो कहिबो ना. Hello, dear participants. Due to some network issue, perhaps the expert is out of the connective area, so please wait sometimes.
We are waiting, ma'am.
Okay, thank you.
Am I audible and is the screen visible? Can anybody give a confirmation?
Yes, sir. Audible.
Okay, I'm extremely sorry because there are some internet disconnection here for some reason. Anyway, what are the slides are there? I will again show you. It is not an issue. Yes, sir. Professor, I'm sharing. Is it visible now? Is the screen visible?
Not visible, sir.
What I have already shared here. Is it visible now?
No, sir, not it is not visible now.
I am just.
Yes, sir, it is visible now.
It's fine, sir. It's fine. Just 1 minute. I take.
Okay. Thank you.
Is it visible now? Any of you give a confirmation? Am I audible?
Yes, sir,
Yes,
it is
it is
visible.
visible now.
Yes, yes.
Huh? Okay, okay.
Yes, it is
Thank you.
visible.
Yeah, thank you,
Yes,
thank you,
sir,
thank you.
visible.
Okay. So just 1 minute. Yeah, we are discussing about the key practices in the sustainable manufacturing. And here one of the important things I was discussing about this circular economy.
Sorry, sir. Please go through. This is the slide mode. It is not in the
Oh,
slide mode.
is it okay now, madam?
Yes, sir.
Oh,
Now it
yeah,
is okay.
thank you for the feedback. So now the important thing we are discussing about the circular economy. What is that the linear economy and what is the circular economy? We'll get some brief idea. In the linear economy, just to take, make and dispose. I was giving an example that in our school days, one pen we are able to. Any, any issue is there? I think somebody has to switch up the audio. Okay. Then in the linear take, make and dispose, a single pen we used to use for 4 years. But now every month you dispose the no refills and everything. It is a small example I am giving. Now we are switching to the circular economy. The model to a circular model where the resources are reused, recycled or regenerated. Example, remanufacturing, upcycling and waste as resource initiatives. Then the important is the green supply chains. In the green supply chains, you see here the partnering with suppliers who prioritize the sustainability and using eco-friendly materials and also the transportation methods. We call it the green supply chains. Then the second part is the optimizing the logistic to reduce the carbon footprints. That is also most important because the greenhouse effect and all things, and there is holes in the ozone layer, all things we know. Then the zero waste strategies, designing processes that eliminate or minimize the waste, because more the waste again the disposal and polluting the environment and everything. Then achieving zero waste to landfill certifications through recycling, compositing and energy recovery. These are the things we come across. Similarly, the eco design is also important. In the eco design, designing products that require fewer materials, use renewable inputs, and are easier to recycle or repurpose. Example, say we go for the modular electronics, we go for the biodegradable packaging. These are things currently the government practices, they ban the polythene or etc. Then another thing is the digital twin. And digital twin, as I told you that, using digital simulations to optimize production process, reduce the material waste and also improve the energy usage. Okay, that is the real-time simulations, whatever you say. That means observing from the current object will be able to go for the reconstruction or the remanufacturing. Then implementing smart factories powered by IoT sensors for real-time monitoring and also for the different type of resources, right? Then see, let us see what are the benefits of this sustainable manufacturing. A number of things are there. First is the economic, it reduces the cost because if you are starting from the scratch and you are recycling and reusing, definitely the cost will be reduced. So reduces cost in the long term by minimizing resources, use and energy consumptions. It builds resilience to resource shortage and also the regulatory changes, right? Then another thing is the environmental things are there. It reduces greenhouse gas emission and other pollutants, preserves natural ecosystems and also biodiversity by minimizing resource exhaustion. So and also reduces the burden on landfills and also waste system or the water systems, right? So then the last one is the social. Here promotes health and safety for workers and also for the communities. It fosters innovation and creates green jobs. A lot of jobs also can be generated. Enhances brand reputations and also consumer trust. Then what are the challenges we can see? There are a number of challenges also existing. Because we have to adopt all the things, high initial cost of course should be there. Adopting sustainable technologies and materials often require upfront investment. Then the complexity of implementations. So transitioning legacy system, existing old system to sustainable practices can be challenging, then require alignment across the entire supply chain. Then the regulatory variations also there, like sustainability regulations vary by region, that is the complicating the global compliances. Then the last one, the measurement and accountability. Here, accurately measuring the environmental and social impact of manufacturing practices, it is complex. Example, let us take some example of the sustainable manufacturing practices or who are the people using. If you see the Apple Inc., it focuses on carbon neutrality, renewable energy use, and also recycling programs for electronics, which is famous for or by the Apple. Then recycling rare earth materials, because so many materials we are using in the components, we call them as the rare earth materials. It reduces also the packaging waste also. By reducing also we can do it. Next company, they are using the Patagonia, then uses recycled materials. Even if you will be astonished, the clothing you are using also, they can be recycled and they can be resell with something. Then you know about the Tesla designs electric vehicles and also operates zero waste factories powered by renewable energy. That they are focusing on the zero waste. Next is the Unilever. This is implements the sustainable sourcing for raw materials like palm oil, reduces water usage in productions. All the things are there, right? So this was the first part of our things regarding the introduction part, and there was some problem, actually power problem there. That is the reason we 1 or 2 minute break was there, but still I will adjust those things. Don't worry at this moment. Now, let us come to our main topic, like the framework for sustainable manufacturing and integrating Industry 5 technologies with the Industry 5 values. And here, from this, you can see in the left hand side bottom that I am talking about something like the Industry 5, and the right hand side bottom, I am showing something the difference between the Industry 4 and also Industry 5. Here you can see that it is human centric, integration is required, sustainability, then data analytics also required, automation is required, digitization is required, circular economy, what we studied now required, customizations, and also
Sir, your screen is not presenting.
Okay, let me check, madam. Is it okay, madam, now? Can you see?
Yes, sir.
Yes, sir, it is
Yeah,
visible.
thank you, madam. Okay. So I was talking about our main topic here, the framework for sustainable manufacturing, integrating the Industry 5 technologies with the Industry 5 values. So I was just giving an example. On the left-hand side bottom, you can see the Industry 5, the diagrams from this. You can see whatever things now we come across, like it is human-centric, we need some integration and sustainability required, data analytics required, you are using the IoT, because in the IoT, a lot of data is generated or acquired by the sensors. Then big data concept also, maybe sometimes you are using automation, then the digitizations using the computer systems, then circular economy, what I just discussing, just I hide this thing, it is not required. Yeah, and the same time the customization and the cyber physical. But if you see the comparison between Industry 4 and 5, okay, we don't waste, I'll give you the details about that one. In this overview of these presentations, we'll be studying about this Industry 4 and evolutions, what are the key features, what is exactly this Industry 5, what is the Industry 5 values, what is the sustainable manufacturing, Industry 5 technologies, integrating technology with values, and building resilient manufacturing systems, and finally, who are the company using this Industry 5. Let us take just here, have a look at the right hand side diagram, you can clearly understand. See, we want to do a live projects, or by Industry 5, it can take altogether whatever we do it here, we can go for the live projects. This is related to the academic part I'm talking about. The intensive placement training, ability enhancement courses, interdisciplinary workshops, international exposure, and also industry visits. This is how we can give some ideas to our students and our faculty regarding this thing. And let us have a idea about the evolution, let us start with our industry 4. Of course, I'll be covering all the things, but mainly we are comparing with the industry 4 and 5. So we'll focus on these things. In industry 4, it refers to the fourth industrial evolutions. 4 means the revolution starting from 1, 2, 3, 4. Now we are at 5. And it is marked the integration of digital and physical system in manufacturing and other industry. Two things are there, the digital system and also the physical system and their integrations. This is what we have done in our industry 4. And it represents a shift towards intelligent, interconnected, and autonomous production process using the advanced technology. That is what we have done in our industry 4. If you see here, the autonomous robots, and we go for the simulations, then we go for the system integrations, what you have done in industry 4. Then you are using internet of things, cyber security, for collecting the data and maintaining cloud computing, then additive manufacturing like 3D printing, augmented reality. I'll give some idea about virtual reality and augmented reality. Then the big data, because all the data what is collected through this IoT and other things, they are maintained, and huge database is created, and dealing with this database, everything is part of this industry 4. Then what are the key features in this industry 4? Let us have a look. Because I have been asked to finish everything by maximum 3:15. So we have exactly 25 minutes in our hand, or 30 minutes maximum. Within this, we will try to cover most of the things. Then, and the key features of the industry 4.0, here the first point is the cyber physical systems, or the CPS. The integration of physical machines with the computational systems, that is the key features in the industry 4. Then also it enables real-time monitoring and also autonomous decision making. Say by use of this artificial intelligence like things, and use of some things like the machine learning related things, specifically while you are going for the reinforcement learning there. So this decision taking or decision making process is also implemented there. Then in the Internet of Things IoT, it connects machines, as you know, and we are using IPv6. Number of devices are there, nodes are there. They are having the IP addresses, and they are connected. They collect the data, and all the things is there. You know about the IoT and IIoT, industrial Internet of Things, and also the various sensors to collect and exchange data. Some are there only unidirectional; they can only collect. Some also they can exchange data, and it facilitates predictive maintenance and also the process optimizations. This is thing what we have using in the industry 4th. In addition to that, we are using the concept the big data and analytics. It handles large volume of data generated by the interconnected systems. Because in the networking or internet networking, we are going for interconnected systems. The same thing where you go for IoT, we are using a number of sensors, number of devices. They are also collecting data who are interconnected, right? Then it provides actionable insights or focus to improve the efficiency and also the quality of the products. Then cloud computing, as you understand, nothing cloud is there. It is just like the centralized data storage, right? And also the processing. Data is stored at a centralized place and also processed with some good things. Like then it allows remote access and also collaborations across this global term. Say somebody is working in Mumbai, somebody is working in California, somebody is working in Perth, Australia. Like that, all people they can work together. There is nothing wrong, because with cloud computing they can connect, and people working here there they can. There is nothing is a barrier for them. Okay, distance is not a criteria for them also. Then the use of this artificial intelligence and machine learning, what I told you, that it enhances the decision making with predictive models and also pattern recognitions. Then it automates the complex processes and improves the productivity. Then other thing is the autonomous robots. Now you can see the frequent use of robots in not only the places of hazards, in the day-to-day work also people are using. That much of use not there in India, but you can see no, getting a servant in India it is easy, but getting a servant to look after the day-to-day work, it is not that easy in the developed countries. They use domestic robots to help them to do all these works according to their. They customize and they use it. Then collaborate with humans and response to dynamic conditions. Then I was talking about this additive manufacturing. The example is the 3D printing. Suppose you want to go for a prototyping or go for a model, so you can do it in the 3D printing. I think most of these IITs and NITs, even I hope there will be a 3D printing unit in our esteemed institution, university kit also. So most of the engineering colleges or universities, they are going for this 3D printing, because it is very fast rate. They can go for the prototyping or creating a model. It reduces the waste and also shortens the time to market, right? So suppose you want to do a market, so you cannot make the dice and you cannot, it is expensive, and because you do not know this is finally approved or accepted. But with a 3D modeling, same thing you can reuse, or you can make different models, and not only the static part, the dynamic part also you can check it. Then the most important part is the augmented reality. So there I thought that some slides I'll be sharing with you, but I'll see the time. With that, some idea I will give you, and the difference between this augmented reality and this virtual reality. It provides real-time visualizations and the remote assistance. I'll tell you exactly. These sentences or the words does not make any meaning to you, I understand. So this useful in training, maintenance, and troubleshootings. I'll share 5 to 10 slides on this augmented reality, where you can better understand what is this augmented reality, how really it is useful for our smart manufacturing. Then smart factories like the self-optimizing, flexible product facilities use advanced analytics to adjust operations in real times. So these are the things we can use. Then I heard what I was talking about this, the augmented reality. What exactly the augmented reality? It is a virtual object in real world. Can you imagine that you are going to, uh, instead of going to a place, you are there in your house and you want to select some furnitures, and you want to see that furniture fits to your room, a dimension same 15 feet by 20 feet or like that. What type of furniture, the colors, the model, the different type of things. So is it that I'll go purchase one, see, then I'll return, they'll take one? Instead of that, sitting in my house using this augmented reality, I can see not only the furnitures, even if the this bathroom, all the things, whatever the tools and kits were using, everything we can see the model. We can check it whether physically it is possible to accommodate it there, and how it look with the actual dimensions as if the real object in the real world. So this is possible, right? Then what happens in this augmented reality? You try to understand it is the digital object in the real world environment. Try to understand these two things. Then here you can see the man with oculus like that, using some sensors here, they standing here and using, and he's interacting. You got it now? So the object can be 2D or 3D, and the real world environment we can see. Using these things we can go for the augmented reality. And what actually this augmented reality AR does, we go for some AR programming. For example, we go for this some video games and all things. The the candidate or the he's there, he's running, he's firing, he's jumping, doing as if he's landing on there and climbing the things. Everything is there. Okay. Then it takes the help of cameras and the smartphones for the various sensors or the cameras, and also interact with the real world object, and also the locations also it can share, right? Then how this augmented reality actually differs from this virtual reality? So I'll tell you one thing. The augmented reality, in the other word we can say, it is an altered version of the reality. The reality, the world is there, but the object is not there. We create an environment such that the digital object fits to the real world, and we can see the functionality and also everything there, right? Then I was talking about this virtual reality. This virtual reality is the fully immersive experiences. That means the object is virtual and the environment is also virtual. But in the previous case, only your object is digital or the things, but the real world is there, right? Now, for this, we need some special equipments. We may be using some, I told you that we'll be using like that, some HTC Vive, like that, the version Focus 3, cost will be around 1.4 lakhs. Like that, we can go for the virtual reality. We are using MS HoloLenses, like the things, and Oculus Rift. If you go for this Quest 3, it will be around 57,000 or like that in USA. That is 512 GB. But if you are using a 120 GB, it will be around 23,000. So all the features will be there. The people who are going for the game development, or they are going for the simulations. I'll give an example here. So there is a physical training for all these military people, because one of my student who is working on this game development, he has taken a project from the government of India, because all these people who are recruited, they are given a physical training, how to go to the terrain, how they take the training, jump, do is that, and valley, ridge, and all things. But instead of physically going there, it is possible to develop a game development like of things, and entire simulation can be done. That means without actually they are put to the there, they can also do all the practices there, right? Then it is best known for the video games or the retail shopping, all the things it is known, right? Then where we are using commercially, we are using in the defense, we are using the education, we are using in manufacturing, you are using in medical. So these are the things, as I told you, that it is a digital object in the real world. We can use the shopping apps, you can the Pokemon game we are seeing. I think most of the young boys, they will be seeing the Pokemon game. It is created out of this reality. Then the heads up display, one AR applications will be there in the, no, you are putting the, there you can clearly see. And the frequently portrayed the science fiction films. I think the young people, they might have seen a lot of movies. They are done using this AR, right? Then AR in the medical field, lot of applications is there. It gives the proper treatment. Similarly, interior design and modeling. So in the 3D house building and all things, what is the interior design and how it looks, without going for the actual things in the augmented reality. Also, you can do. You can choose their color, their favorite paints, and everything. Then learning and development also, after these pandemic conditions, I think the India has widely converted to digital India, because most of these, academicians, professor, researchers, they delivered not only the theoretical things, also labs and also learning materials. Okay, that means training the employees from anywhere it is possible, even if the operating a patient with some machinery online, that is also possible, and it is also risk free nowadays, right? Then the product designing, if you are starting from the scratch, it takes consumes a lot of time and also resources. But using this, it is easy and also saves a lot of money and time, right? Then it improves the quality and also the cost is low. So if you go for this entertainment in games and other things, so you can see there is wide application in the games and increasing visibility. Then the like swimming pool, football field, and racetracks, everywhere you can use all the things. Then the future of augmented reality, it is good. You can see there is a positive feedback given by many people who are using. Google is using, Amazon is using, Microsoft is using, Facebook is using, and AR-based software and applications, it is increasing just in the exponential form, right? And you'll be astonished to know US is able to get around $6 billion using this augmented reality. So it has a very good future and picture. And image enhancement by 2025, a lot of things are there. So this is what exactly I thought you that on 5.6 slides I'll be sharing with you on this, augmented reality and virtual reality that I did it. Now let us see the evaluation of this industry 4. If you see starting from the beginning, if you see here, in this diagram, I can explain you. The industry 1, it is just the mechanization, and industry 2, it is the electrification. Industry 3, it was the automation, and industry 4, it is the cyber physical system integrations. Try to understand these things from this single diagram. You can clearly understand. Industry 1.0 revolution, it was the mechanizations like the, the wheel and the all things. Then the electrification and the motors and all things, it came into industry 2. Then industry 3, the automations and automizations, all the things it came, automatization. Then the industry 4, that is the cyber physical systems, all the things it came. And if you see here, I have given in details. In the late 18th century, industry 1 came into being, and this was the age of mechanizations powered by steam engines and also mechanized tools. That is the transition manual productions to mechanized systems. It was there dominating in the 18th century. And in the late 19th century came the industry 2. That was the age of electrification, that is the adoption of assembly lines and mass production enabled by electricity and also advancement in
Sir, it is not audible.
Sir, due to the network issues, he is out of the connectivity. Please bear this big due to the weather condition. It is happening.
Okay, madam.
Sorry for the interruption. Uh, Once again, I connect you here. Go here, share. Is it visible? Is the screen visible?
No, no.
Maybe it takes some time, but I am audible, I think. Is it visible? The screen is
Yes, sir.
visible?
It is visible
Now
and
it is
you are
visible, sir.
also
Yes,
audible.
very well.
Thank you. Thank you. Thank you very much. Yeah, we are going for this evolution of this industry 4. Starting from this industry 1, 2, 3, 4, the same thing I was talking. In the late 18th century, it was the age of mechanization. And industry 2, that is the late 19th century, the age of electrification. That is the adoption of assembly lines, mass productions, enabled by electricity and the advancement in the communication that the universe has seen during the industry 2. Then industry 3.0, it is in the late 20th century, that is the age of automation. Here the introduction of computers, electronics, gadgets, and the programmable logic controller, the PLC, what I was talking, that most of the electronics communication people and triple people also, they can understand. Why? Because all people, they can understand, because this PLC we are using most of the places. And this focused on automating repetitive for efficiency. What is the thing? That for this similar work or repetitive work, instead of using the technical brain there, we can use a machine to do that one. And this brain, we can use it for innovation or for some other type of work, right? That is the thing there. Then industry 4, it was there in the 21st century. This is the age of digital transformations. Here merge the physical and digital systems to create a intelligent ecosystem. That is the one. Then it is driven by the data. What is the important thing? Why you are using the digital system? Because you are integrating with the data. A lot of data was available, trillions of data was available. If you insight and focus on this data, a lot of things we can collect and we can use. Then connectivity and also advanced computing technology. These are the things we use there. Then I have shown you this diagram. You have seen industry 1 was mechanization, industry 2 was electrification, industry 3 was automatization, and industry 4 was cyber physical systems, right? Now, what are the key benefits of this industry 4? Because we don't discuss in details about 1, 2, 3, 4 and 5 little we will discuss. Then what are the things in the 5 and what are the values that we'll discuss. And in the smart industry, how we are using that will smart manufacturing. Here, uh, industry 4, it was used for efficiency gains. That is the streamline process, reduces the and optimizes the resources. It was the main thing in our industry 4. And second thing, it was used for customization. It enables flexible production for personalized products, sustainability, reduces waste and energy consumption also reduced through smart systems. Then global connectivity supply chains. Then improve the decision making by using the real-time insights, by using artificial intelligence, by using IoT, things like this, or different algorithms also. Then what are the challenges? The integration cost was high initially. Investment was high to upgrade the technology. Data security was a great risk and challenge. Increased risk of cyber attacks with the interconnected systems. Then workforce readiness, need for reskilling to adapt to advanced technology, because simply bringing technology is not a solution. The people who have to work with that one, they should have the technical knowledge and also the expertise. That is the reskilling. You see, when the government introduced the computers in maybe 1991 or after that, the people, they, even if they do not know how to use the Microsoft Word, so it was a great challenge that time. But anyway, lot of training was there, and a lot of no workshops were conducted. Then only we are able to use. Now it is a common thing. Anybody in the standard 3 or 4 also knows the use of computers. But it was not the scenario in 1990s or 1990 to 95. Then the complexity, the managing vast amount of data and diverse technologies is also some complexity. It was then the transition to industry 5, while in energy, emphasizes the human service, sustainability and resilience. These are the uh, what is the resilience and sustainability. Then consider industry 5 represents significant the manufacturing of of what you say, the food going to replace all these, not like that. Mm, Shall I continue? Connect. Shall I continue or?
Yes, sir, you can continue.
Okay, thank you, madam. Because of some extreme weather, the network some problem with that. So then I speed up these things. Then the personalization, and also here we are going for this customized production, the consumer engagement. See, the thing is that this consumer engagement is also important. It focuses on personalized experiences, foster stronger relationship between the business and all the consumers, allowing for greater customers feedback and also involvement. Okay, the agile model is that that is the same thing they used to do there. Then integration of advanced technology like artificial intelligence, machine learning algorithm, IoT and smart sensors. Then the resilience and agility like the manufacturing system we are using Industry 5. It emphasizes the need for production systems that can quickly adapt to changes. That is the uh, agility, whatever you are saying, resilience. Then supply chain resilience is also there. Yes, I'll within 5 minutes. Then you can see the key difference between the Industry 4 and 5. Here I told you that it centers around this enhanced efficiency, technology and all things. Here it is a framework, emphasizes the impact and alternative modes, empower workers, builds transitive pathways, all things are there, right? Then coming to the Industry 5 values, the I was seeing that madam was talking about that some education for all. There I've seen the inclusivity. It is a great thing. So it is just like involving all the stakeholder in the decision making process. That is the main idea in the inclusivity. Then the social responsibilities, companies are encouraged to take responsibility for their social impact, focusing on ethical practices, fair labor conditions, and community engagement. And this aligns with the broader trend in corporate social responsibility, that's CSR. Then the transparency, then the innovation, well-being. So focusing on these, all the stakeholders, all the labors and everything. Then this Industry 5 represents a transformative shift in the way industries operate, focusing on the synergy between human intelligence and also the machine efficiency. Then the sustainable manufacturing, as I told you that it is an evolving paradigm that addresses environmental, economical, and also social sustainability in production processes. So with this emergence of this Industry 5, it emphasizes the human-centric, sustainable, and resilient production systems. Yeah, so these are the Industry 5 technologies like the collaborative robots, artificial intelligence, digital twin, IoT, additive, and you can see the different values here. So these cobots, I'll show you some diagram you can understand here. See how the cobots are using, how they're interacting the human beings. Then you can, other companies who are using the Nike, even if they can customize the human shoes and everything on the spot, there you can see how they're doing. Then the aerofarm and also the cement, how they're using, see how they're going for these leafy greens, using the nutrient spray in different places, solution chambers without a soil also they're able to go for all the things they're doing. Then similarly, the Philips Healthcare Smart Cities, you'll be knowing about the you can see the Barcelona Smart City, how things are there. You can see the city semantics, analytics, city operating system. Here, the situation room, control centers, applications. You can see here the territory geo and city data, the open data apps. All the things are integrated using all things, right? Eco-friendly fashion, digital twin technology. The digital twin will have an idea through IoT how they are seeing the object here. From this they can collect the data and they can go for the visualization, they go for the model, and they use the artificial intelligences and also the automatically analyze, and finally through cloud computing they all store the gain data, and also they can reconstruct all the things, right? So some digital food productions, all the things, cement, these are the people they are using, right? Then something we have the idea about the Tesla's idea about harnessing the atmospheric. These are the slides I'll be sharing with you, and I think with this we'll be able to have some idea, basic idea about what is this, no, this is smart manufacturing and what is this framework, and also Industry 5 and its value. So I'll be happy to invite a couple of questions from this audience, and I have given my email ID and also the mobile number. You'll be free to post a message to me or send to me. Thank you for this opportunity to give to share my ideas in front of all the the distinguished delegates and also the technicians. And thank you. With this, I hand over because I was assigned up to 3:15, so it is over to the people. Now I am open for some queries or questions. Thank you.
Yes, Dr. Satyajit Dhota, please, if you have queries, please ask the question.
Excuse me, ma'am. Good afternoon, sir.
Very good afternoon.
Really, your deliverance is soul stirring and heart touching. And one thing, sir, one doubt is there with me. Can you please tell me, sir, what is the which is better for the industry, the augmented reality or virtual reality, sir?
So as I told you that they have different purpose. Augmented reality, it is a digital object in the real world, and where it is suitable. So I told you that while you are going for this game unit, or while you are going for say suppose you are a wholesaler and a customer wants to talk to you, that you are dealing with all these appliances or all these furnitures. So without physically visiting your company, a customer can see those things and they can see whether it is suitable or it is fitting the color and everything is in the, he can decide without visiting that one. That means it is a digital object in the real world environment. That is the job of the augmented reality. But in the virtual reality, the object is there virtual as well as the environment is totally it is virtual. Okay, so that's why it is specific when you are using for game development, when you are using for this type of things, then you can go for the augmented reality. But when you want to go for the complete digitization, then you can go for this virtual reality. So I think I answered your question,
Thank you.
Professor Hota, and thank you for this nice question.
Thank you, sir.
Thank you.
Any queries? So perhaps I think that there is no other queries. So thank you, sir. We are on the behalf of the organizing team. I am very much grateful to you for accepting my invitation as well as deliver your expertise. So, sir, there is some problem due to the bad weather. So, sorry for the inconvenience from the uh, organizing team to the participants. So, thank you so much, sir. We are very much grateful to you. Thank you for the
Thank you. Thank
transformation
you.
of Industry 4.0 to the 5.0 in the manufacturing factory. Thank you. It is a admirable talk.